Hello, guys, and welcome to today's session, Grade 10 Physical Sciences. My name is Temba Ngube. Today we are focusing on physical and chemical change, which is pretty much a build-up from the previous lessons. Now that we have looked at the chemical bonding, now we want to understand how matter behaves as far as physical as well as chemical changes. Let's hope we have a very wonderful session for today, and we have a lot to take out from today's session. Your participation and your involvement in this will be very crucial, guys. Okay, let's briefly look at the overview of today's session to get a sense of exactly where we're going today as far as physical and chemical change. Right. Okay. Right. As you can see on the board, we have got matter, which consists of atoms. Remember, these atoms are the smallest particles that make up matter, and these atoms, when they combine, they form elements. Right. Remember, as far as atoms are concerned, atoms can achieve stability through chemical bonding, right? So when chemical bonding takes place, we describe the three types of bonding, which is covalent, right? We also have ionic, as well as metallic. Right. So this is between atoms. So chemical bonding occurs as far as atoms. Right. Atoms of different elements, they bond with each other by way of sharing electrons or possibly by transferring electrons. Or it could be the special case which involves the metallic bonding, which we discussed in the previous session. Right. Now, having said that, once these chemical bonds are formed, we have compounds. Right. Compounds, you can talk of your water. Right? As an example, your carbon dioxide. Now, you realize that as far as compounds are concerned, it's two or more different elements or atoms of different elements that chemically join together by any one of these three forms of chemical bonds. Now, we have also cases where we form molecules of covalent compounds or molecules of elements, right? In which you can have, for example, chlorine is a molecule of an element, carbon dioxide or sulfur dioxide as an example of molecules of compounds. Right. Now, as far as ions are concerned, it has a lot to do with the ionic bonding. Right. Now, because we want to understand how matter behaves, right, under different conditions, matter can undergo what we refer to as a physical change. Now, physical change is another broader aspect of today's unit, in the sense that when we talk about the physical changes, I would use, for example, water. You know, when you heat it, it changes its state or its phase. However, the chemical composition of the substance remains entirely the same, in the sense that whether it's gas or liquid or ice, the formula will still remain H2O. In other words, the chemical composition remains intact. However, what changes are the intermolecular forces, or these forces that exist between molecules of the same kind. So as far as physical change, it has a lot to do with intermolecular forces, yet chemical change has to do with the atoms and the chemical bonds between individual atoms of elements that are involved. So the broader sense of it is that as far as physical and chemical change, it has a lot to do with how matter behaves under different conditions, let's say of energy. You know, two things may happen. You can either have a physical change or a chemical change, which is basically what is of interest to us in today's session. Right, let's quickly look at the key concepts without any waste of time. The first one that we shall look into as far as the key concept is the separation of particles. Right, now, as far as the physical change is concerned, remember, particles in this case, it could be molecules, you know, that we're talking about. It could be molecules, let's say, of water, you know, molecules of water being intact as they are, composed of two atoms of hydrogen as well as an atom of oxygen chemically joined together. So now this involves physical change, involves molecules if it's covalent. You know, remember, molecules are formed by covalent bonding, and it could be molecules of elements or molecules of compounds. Ions obviously have to do with ionic bonding, right? Ionic bonding, in the sense that you could have, remember your cation ions, let's say X plus, it could represent any element, and then let's say Y minus. Now these are the ions involved as far as ionic bonding is concerned. And then, or atoms that change the arrangement. Now, we looked at, in the first quarter, we looked at how let's say, for example, the 3 states of matter, which we discussed in terms of solid, liquid, gas. There are quite a lot of differences as far as the arrangement of particles is concerned. If, for argument's sake, you can start with a solid, let's say ice, you think of the particles or these molecules, at that microscopic level, we could think of these particles being closely packed together. So the arrangement or the packaging speaks to the physical state of a substance or matter, for that matter, or for that reason. And also, we can also think about when water melts, or when a metal is heated at very high temperatures, what would normally happen? It will change into a liquid substance. Now, as far as the arrangement of particles is concerned, in a liquid, particles tend to move past each other. They're not as closely packed as they are compared to the liquid. And then the gaseous state, think of water vapor or steam for that matter. Now, if you heat it, what's going to happen? The molecules are still H2O, right? The molecules are still H2O. It's still the same thing. What has changed the arrangement of the particles is the intermolecular forces, as we have referred earlier on in our overview. So the intermolecular forces have a lot to do with the arrangement of particles. So in a typical physical change, it has a lot to do with the arrangement of particles, change of state, as we shall establish as we go further into today's lesson. Right. Also, in a broader sense, just to show differences between these two, a chemical change has a lot to do with chemical bonds. The chemical bonds that we talk about now is, let's say, for argument's sake, ion, rusting, in the presence of oxygen, if I may use the symbols, okay, then you get iron oxide, something like this, which we did as far as chemical formula is concerned, iron oxide, okay. So now the bonds are which are formed when this new substance is formed are between the atoms. So there is some element of bond breaking or some aspect in terms of breaking the bonds between the water molecules so that there is rearrangement of the particles. Yet, as far as physical change is concerned, it has to do with the arrangement of the molecules or ions. However, the chemical composition does not change. But in a broader sense, I think that sets the two types of changes apart. Right. Okay. Moving forward. Okay. Right. Now, let's look at the bolts and nuts of a physical change, which can occur and be measured without any change in composition. Now, in terms of change of composition, let's say, for example, you've got ice. Ice, as you know, it's water in solid state. Okay. If you heat it, okay, let's heat it. Okay. If you heat the water, what happens? It's still the same substance. However, when it has melted, it has changed its phase to liquid. So the chemical composition remains constant. In other words, it remains the same. In other words, what it says to us, we do not form any new substance. If you look at the substance on the left-hand side, before energy was supplied, energy in terms of heating the ice, and what you have on the other end after melting has taken place, it's pretty much the same substance. Hence, we maintain that the chemical composition does not change. Right. Now, there are types of changes that have to do with the physical change. There's change of phase, and when we talk about change of phase, we're talking about gas, okay, liquid. These obviously come to mind. Hence, it's not something that is entirely new to us. Gas, liquid, as well as solid, right? So it involves the changing between these 3 states of matter. Remember, the broader sense of physical change is that the chemical composition remains the same. And also we say that physical change has to do also with the behavior of matter under different conditions. So if you want to think of it in terms of maybe heating or supplying energy so that these particles, they tend to move faster. Once that happens, the arrangement of the particles change. Once the arrangement changes, obviously, consequently, we would have a change of state in the event of, in the case of what you call the solid being converted to a liquid, and when you further heat it up, then it becomes a gas. Now, what has changed entirely is the arrangement of the particles. However, the chemical composition remains constant or the same. It does not change. Right. Now, also, we've got change of shape. If you take, for example, ice, an ice cube. If you come to think of it, it is a definite shape. If maybe you can realize that cube, so that is a definite shape. Now, if we heat this substance, if it changes its phase into a liquid state, it has no definite shape. If you put it in a U-shaped container, it will take that shape. That's basically what happens. So the change of shape has taken place due to change of phase. So I would want to think these two also can be related one way or the other. Right. And also, there's also color change. If you talk about color change is qualitative. It's something that you would observe. Let's say, for example, you heat an element of a cake, it becomes white hot. You heat an element of a heater, during the cold winter season, it changes color into red. But that is coupled to energy input as well. Now, you'd want to think of it in this way, that as far as the physical change, these are the three possible observations that we can make. There can be a phase change. So the key word phase is key, shape, as well as color. Right. We shall delve much more into detail as we go forward. Right. The characteristics of a physical change these are some of the key pointers that we need to take home at the end of the lesson. After all has been said and done, we need to be in a position to say, okay, how then do we tell that this is indeed a typical example of a physical change? Hence, we're speaking to the characteristics of a physical change. Now, energy is involved, as I've alluded earlier on. The heating part, when you heat particles, let's say a substance which is in solid phase, if it's going to melt at whatever temperature as you'd want to think of it. Now, what happens is energy must be supplied to these particles so that the intermolecular forces between the particles, remember, for a physical change, our reference is to the intermolecular forces. So energy must be supplied so that we break and weaken the intermolecular forces, or the electrostatic. Intermolecular forces would be your typical, covalent, covalent. And then the electrostatic would be your typical ionic compounds. But remember, for covalent, it could either be elements or compounds. Now, in other words, also, the physical change is also reversible. If we're talking about a change being reversible, it means, say, for example, the ice that we spoke about. If you heat, you supply energy, the intermolecular forces become weaker, and then it changes phase. Now, once in liquid state, we are in a position by physical means, again, to reverse and get back the solid by possibly, cooling it. Typically, maybe you would do that by putting it in a deep freezer, which is something that happens in our everyday life. So I would want also to emphasize the importance of the fact that a physical change could actually be reversed. In other words, it can go either way. Energy is required. However, the amount of energy comparatively that is required for any physical change is relatively smaller. Right. Okay, let's move further. These are the examples of physical changes. Now, during phase change, the state. So the word state and phase at this level, we shall use them interchangeably to refer to one and the same thing. It would mean maybe a transition from the three states of matter: your solid, okay, your liquid, your gas. Now, if we talk about phase, we're talking about these three states. Remember, in its entirety, this has a lot to do with how matter behaves under different conditions. In this case, when we talk conditions, we're talking energy. Right. Now, the chemical change, the chemical composition of the substance remains the same. Chemical composition, we're talking about the individual atoms that make up a substance. Let's take, for example, dry ice. Dry ice, the one that we use, for cooling. Dry ice. dry ice is a common name for a substance which we use every day, which is carbon dioxide. But dry ice in this case will be in solid dry, because ice, it's in a solid state of phase, as I've alluded earlier on. Right. Now, if it sublimes, we shall talk about sublimation and what that it means. But in grade 8, you would have spoken about or dealt with change of state of matter. Sublimation, it means it changes from solid to gas, or from gas to solid, either way. Now, if you check, this is a physical change. The chemical composition is remaining the same, or it hasn't changed. We still have got one carbon atom, right? One carbon atom. And then also we've got 2 oxygen atoms, right? Now, and also we are talking about the forces between the molecules. So say, for argument's sake, this was your carbon dioxide molecule, and we have got another carbon dioxide molecule. Remember, carbon dioxide is a gas, so these intermolecular forces, in this case, are weaker. But when it was a solid in the form of dry ice, they were closely packed together. Now, what has changed in this case is the arrangement of particles now that they've acquired energy. So this will be your typical solid, and then in this case, it will be your typical gas. The forces are weaker. Spaces, there are more spaces between particles, and particles now have got greater kinetic energy. So we shall talk about that later as well. Now, so this represents a typical physical change, wherein the chemical composition on the left is the same as the chemical composition on the right. The only thing that has happened here is the arrangement of particles. Right. So when ice melts to form water, we've spoken about that as well. It's a typical example of a physical change. The evaporation of water to form water vapor. So water, I think in everyday spoken language, would immediately think about the liquid state in which the common substance exists. However, if we heat it, it's still the same water. However, it has been changed its phase. Now these particles are further apart. The arrangement. So emphasis is on the arrangement of particles, with the chemical composition remaining constant. Right. Now, the condensation, these are your condensation, your freezing, your evaporation. We will we'll refer to these as the physical processes. So these are the processes, okay? So these are the physical processes. That's why we say these are physical processes, because they involve a physical change. Now, just to also highlight some of the very key things. Melting is to do with that kind of phase change. It's from solid to liquid, freezing, liquid to solid. Now, in other words, we can juggle between these two. We can move from liquid to solid to liquid, as well as liquid to solid. So hence, this talks about the fact that the physical change is reversible. Now, reversible certainly means in this context that we can move from left to right or right to left, with very minimal amount of energy, as we have suggested earlier on in terms of that change. So we also have evaporation, which has to do with liquid to gas, condensation, which has to do with gas to liquid. There's another misconception that I want to bring. The boiling is totally something else. As many times learners will often confuse boiling and evaporation. I think at this level, we'll talk about the phase change being evaporation, because boiling point has further scientific implications, which I shall deal with in the 11th grade next year, possibly. Right. And then as far as sublimation, we have made emphasis that this does not have to go through liquid state. So it's either solid to gas or gas to solid. Right. Now, these are the physical changes. It's also very important for us to establish the key links in terms of how these processes fit together. Right. Now, say, for argument's sake, we start with solid. Let's say it's ice, Let's say that is ice. So if you heat it, it melts. So the red, it means energy must be supplied. So we supply energy in terms of heating. Right, very key. Right, the blue means energy is released. Right, remember, when you cool a substance, the particles tend to have lower, what we call kinetic energy, which has a lot to do with temperature as far as kinetic molecular theory, right? Something that we'll do with in grade 11, right? Now, so as the liquid is heated further, it turns into a gas, right? So the gas, the particles will be further apart. But sublimation, very key for us to understand that it's either from solid to gas or gas to liquid. They cannot occur at the same time. It's one after the other. Right. With that kind of insight, I think we now have a clear picture of what exactly a physical change entails as far as the examples that we have tackled for now. Having said that, I think we need to take a short breather. Then after, we'll meet each other after the short break. Right, welcome back, guys. Again, remember we're looking at physical change and chemical change, grade 10 physical sciences. Right, we have briefly looked at the physical part of today's focus area. Let's look at exactly what happens during a physical process, or a physical change. Right. Right. Remember, during a phase change, the forces, remember these forces, we refer to them as the intermolecular forces. So generally speaking, we shall refer to intermolecular forces, which are between particles, not the atoms. So the intermolecular forces are between the particles of substances. It could either be between, let's say, for argument's sake, we spoke about the dry ice, between the carbon dioxide molecules. Now, we're not talking about the bonding yet. So as a result, the bond that exists, or the covalent bond that exists between carbon and oxygen, the covalent, having looked at the chemical bonding. So the covalent bond are not broken or are not disturbed. What is going to be disturbed is the forces that act between these carbon dioxide molecules. So as a result, no new chemical bonding it takes place. So when we talk about new bonds, we're talking about chemical bonds. The chemical bonds are not disturbed. They remain intact. They're not disturbed in any way during a phase change. A phase change, we're talking about the change from solid to liquid, or as a typical example. So these molecules are separated. If these are the forces that act between the molecules, it means they'll be separated. Now, these molecules are free to move, which would obviously change what we referred to as the arrangement, which is a critical aspect of a phase of matter. Right. Now, it's also very important for us to understand that molecules separate and move away from each other, as we have indicated there. During the phase change, whatever remains constant, that which remains constant is basically that aspect of the substance or matter that does not change. So when we say something remains constant, it means it's undisturbed, it doesn't change at all. So let's briefly look at what exactly does remain constant as far as a physical change is concerned. The size of particles. Suppose this was the size of the water molecule, just as a model. Now, it will remain the same. It won't change after a physical change. Suppose it was ice and these particles were closely pegged together. It means that these particles, the sizes will remain the same even after these intermolecular forces or these forces have been broken. So we still have the same size, but what would have changed is your typical arrangement of particles, which is very, very key. Right. Now, the shape of the particles. If this is the water molecule, let's say, for argument's sake, it looks in the manner in which I've presented it, it will remain the same. And also the number of particles. This speaks to a very, very important principle or law. Remember, in science, quite a number of laws guide us in terms of the understanding of our science. We know that if you're going to take whatever you put in, whether it's a physical change, let's say the amount of ice that you put in, if it's a particular amount, it will, if after the physical change, it will be of the same amount. So, that speaks to what we call the law of conservation of matter, law of conservation of matter, of mass or matter, because which is something that we shall talk about at a later. So this remains constant. It does not change. We briefly referred to energy. Remember, we said that if you heat a substance, if that substance is in solid phase, a small amount of energy will be absorbed, just to break the forces. So the amount of energy involved in a physical change is also very important. So there is transfer of heat, which can cause a change in temperature. Remember, we said in the first term when we looked at the heating curve of water, we also agreed that the kinetic energy, which we said is EK short for kinetic energy, is an indication of the temperature. So the temperature is to do with how fast particles of a substance move. So you'd understand that the temperature of a gas is comparatively higher than that of a solid and the liquid. Why? Because these particles tend to move very fast and haphazardly. So they tend to fill every available space very quickly. That has to do with the kinetic energy. That has to do with the movement. Right. So during phase change, that energy is added or removed. If we add, it means particles move faster. So adding means higher temperature. Okay. Higher temperature. Okay. Then if we remove, in this case, it means a lower temperature. Right. So the lower temperature suggests that we are cooling, cooling, which is also coupled to a phase change. So if we cool, what happens? The kinetic energy of the particles gets lesser and lesser. Once that happens, the arrangement of the particles would also change in the sense that the spaces become lesser and those intermolecular forces become more prominent or more stronger. Hence, you have got a substance solidifying as you cool it, or freezing. So freezing is that particular physical change that we spoke about earlier on. Right. So that is also very key. So the forces of the particles strengthen. It means they get stronger, which also affects the arrangement of particles, okay? Which is the very key aspect of what? Of physical change, right? Also, there's change of color, during a phase change. The chemical composition remains the same. The color may change due to different varying amounts of energy. We spoke about the element of a cake. You heat it, it becomes white hot. Some, they become red hot. But what is important, the chemical composition, or what exactly makes up that the element in this case, I'm talking about that heating material, not in the context of the periodic table. It will change. It glows, it becomes red. You think of a filament of a light bulb, it also glows with energy, but once you switch it off, it changes. Okay, so that's a typical example of a color change as far as a physical change. However, it's also important for us to emphasize that it's temporary due to heating or cooling. Right, temporary, it means then it will get back to its normal state or the usual state. So the example is when you heat a red iron, a metal, you heat it, it becomes red hot. Sometimes we describe it as red hot. So this is a typical or a qualitative indicator that this is indeed a physical change. And when it cools down, the color disappears. So disappearing, it suggests that it is temporary, just for a short period of time. A stove in a hot plate is a physical change. However, we need to note the fact that not all color changes indicate a phase change. There are quite a lot of examples, in chemistry that we shall talk about, but we need to guard. This is just for most commonly, we would expect that if there's a color change, it will be a physical change. However, not all color changes represent a physical or a phase change. Right. Okay. Now let's look at quickly. Let's look at the chemical change, which is the key aspect of today's lesson as well. As far as the chemical changes, there are quite a lot of differences between the chemical and the physical change. Now, if you look at the chemical change, we're forming new substances. Now, this, I would carelessly put it this way. If you can think of a chemical change, maybe in the context of a reaction, right? A reaction, we form new substances. It involves now the chemical bonds. These chemical bonds, it's your covalent, We spoke about those, which has to do with the sharing of electrons between atoms. So chemical changes involve atoms, combining with others to form, new substances. It could also be ionic. It could also be metallic bonding. But metallic bonding, remember, it's a special type of bonding which involves metal atoms only. Right. So these forces between the intra, it means between molecules. It means between atoms in a molecule. So this is between atoms, okay, in a molecule. Because remember, all covalently bonded substances are molecules. They could be either molecules of elements or molecules of compounds. Ionic, we talk about electrostatic or the Coulombic forces, right? Remember, your cations that we spoke about, Na+, and Cl-. If these two react together, they form these two ions combine, they form a new substance, which is NaCl, sodium chloride. So there's rearrangement so that we form what we referred to as new substances. Now, that's why I said it's very important for us also to think of, a chemical change as a reaction. When new substances are formed, what is very key is that energy is released. Right, we shall talk about how energy is released when new bonds are formed. But generally, whether it's an ionic substance or a product or a ionic substance is formed or a covalent, when new bonds are formed between atoms of the same kind or different kind, energy is released. Hence, we say that energy is involved in both chemical as well as covalent bonding. Right. So, in other words, we also want to make it clear the fact that there will be new forces due to new bonds. These are new bonds. Now, once you have new bonds, now you have new substances. These new forces give rise to new substances. Now, as far as chemical changes, let's take, for example, the rusting of iron. If iron rusts, it's very difficult, if not nearly impossible for us to get back our pure metal after the oxide has been formed. So most of these chemical changes, generally, they are not reversible by physical means. Physical means, it means in terms of changing energy by cooling, heating, filtration, all those chromatography. We mentioned those physical techniques in the first term. But now, as far as chemical changes are concerned, most of these chemical changes or chemical reactions, they are irreversible, which means they are not reversible. Right. Now, so also, which is very, very important. Now, the new substance form differ from the original. Now, if they differ, hence the emphasis on chemical change is that we have got what we call new substances being formed. So that's the key thing. Yet in the physical, we talk about the rearrangement of particles. Now, this is an example of a physical change. Iron as being the common metal, and then which is grayish in color. When it reacts or it combines with sulfur, it means now the metallic bonds between iron atoms, between these ion atoms, must be broken down by supplying energy, so that these ions, the ion atoms can be free to associate with the sulfur, to form that iron 2 sulfide. Now, in other words, the bonds between iron and sulfur have been formed. In this case, we get your iron sulfide. So it means there's intermolecular forces which are formed. Hence, we have a new substance. If you look at what you have on the left versus what you have on the right, the chemical composition is exactly the same. However, the arrangement of particles in terms of new bonds being formed is different. So on the right, we have got the products, which are a new substance. That's what I would want us to think of it as. They're the new substances, which are different from the ones that we have on the left. So chemical composition has changed. And also, if you check, iron is generally a magnetic substance, and now sulfur is non-magnetic in terms of physical property. But you check, this new substance that we form is non-magnetic, which consists of a magnetic and non-magnetic component. Now, new bonds have been formed. Now, this new substance has got its own new physical property. Right. Okay. Now, there are two types of chemical changes that we must know at this level. The first one is synthesis. Synthesis has a lot to do with making up or building. Making up or building. Now, in the sense that we have simple substances being converted to complex substances, okay, to something which is more complex. You think of it, for example, in terms of photosynthesis in your life sciences, just to integrate a little bit, photosynthesis. So it means, in this case, synthesis, making up using light. So this is a typical example of a reaction which involves building up. So we've got, for example, in a general case, we'll have, let's say, A plus B. A plus B, A are simple substances, we can think of them as element. And when they form new bonds, you get something like AB. So AB, new bonds have been formed between A and B. AB is a new substance compared to this, which was being formed by this. But however, like I said, if you look at the chemical composition of A and B, compared it to A and B, it's a little bit different. It's somewhat different. So we'll think of this as a new substance. So this is, in a general case, what would happen as far as new substances are formed in a chemical change. Right. And also, we have what we call a decomposition. The word decomposition means break down. It means to break down. Right. So it means here from complex to simple substance. From complex to simple, then this will be a typical a decomposition kind of a reaction. So remember, the word reaction in this context would refer to a chemical change. The reaction would refer to a chemical change. So comparatively speaking, in terms of energy, remember in the physical type of change, we said that little amounts of energy are required for us to realize a physical change. But now we are saying that as far as the chemical change is concerned, we require a relatively large amount of energy to form new substance. Why is that so? Because we want to, first of all, break the intermolecular forces, right? Then thereafter, we also need to break the bonds. Now, bonds, these are between atoms of molecules. It could be ions, That's why, comparatively speaking, we need a lot of energy for us to realize or to have a typical chemical change or a reaction compared to a physical change, in which the composition or the arrangement of particles is what changes, but the substances generally remains the same. Right. Now, not always they're not always reversible. We've made an example with the one of iron rusting, and even the one of iron sulfide, iron 2 sulfide. It also is a typical example of a non-reversible reaction, right, or chemical change. So the chemical composition changes during a chemical change. Remember the iron 2 oxide, iron 2 sulfide, right, in the previous example. So the iron 2 sulfide, in other words, it consists of iron and sulfur in that way. Yet, on the other end, we only had simple elements like iron and sulfur. But you can also think of this as a synthesis, because these are simple substances which combine or form new bonds to form a comparatively more complex substance. So this is an example of what we referred to as a synthesis reaction, or a synthesis type of a chemical change. Now, we break the bonds and form new bonds. But what is very important, that during bond breaking, because we want these forces which exist between atoms in a molecule, we need to absorb energy. Energy is absorbed. So energy is absorbed. Guys, energy is absorbed. Right. So this happens during bond breaking. Now, during bond formation, we release energy, as we saw in the layout of that flow chart. Now, so as a result, we have new substances due to the rearrangement of the particles. Right. Having said that, I think we have highlighted the very key aspects of a chemical change, in the sense that a lot of energy is involved. Particles or atoms are rearranged, and then we get new substances and new bonds being formed. Right. Now, having said that, I think we'll take a short breather for now, and then we'll join each other shortly after the break. All right, guys, welcome back to our session. This is the last segment where we shall entertain a couple of questions based on what we've discussed in today's session. I also want us to pay careful attention that today's session was mainly as far as concerned with the differences and similarities in the various aspects of a physical as well as a chemical change. Right. Having said that, I've got two questions for us today. This is what is going to happen. I'll give you the first set of questions, then maybe a couple of minutes, because they are based on basic recall, very lower order problems. They're not very difficult. Then you attempt those, then we'll consolidate and then move to the last question. Right. The first question has to do with the types of physical change. Okay, emphasis is on the physical change that can occur. What types of physical change can occur? Right, and then identify the types of physical. This is types of physical. Identify. Now we are identifying. Right. Now in the first one, we are only listing the types of physical change, right? And then there are examples of physical change. Ours is to classify one into the three categories that we have, right? I'll give you 2 minutes to attempt those. Let's go for it, guys. Right, guys, welcome back. Hopefully you have made your attempt on the third set of questions that I gave to you. Now, the first one, we want to identify the types of the type of physical change. Right, we've got a phase change, as you can remember. Phase change, solid, liquid, gas. It can be a change of phase. It could be a change of color, right? We spoke about that as well. It could also be a change of shape, right? So these are the three forms in which physical change can take place. So this question basically has to do with recalling or remembering what we discussed in today's session. So those are the three very important types of physical change. Then the next question, which deals with the examples, if we use gold to when gold is used to make a jewelry, remember it has to be molded into a shape. So it has to be, and at room temperature, gold is a solid. So it has to be in a molten state. So this has to do with the phase. Then when it sets, it takes that shape. So these two, this can be a phase as well as a change of shape, because if I would also accept the change of shape. but also it has to do with the phase, because to mold it, into a different shape, because gold is a metal. Remember, it is malleable. Okay, so if it's malleable, it means it can be molded into a shape, any shape. Then if the heater element glows, the element here is that material which releases a heat energy, due to maybe it's plugged into an electrical source, like it could be your kettle, the one that we use for boiling water, or the heater during a cold winter night. Now, so if you heat it, this has to do with the change of color. But you must realize that as the element is glowing, it's only changing the color, but the makeup or the composition does not change. The same applies to the gold. It can change the phase and shape, but it's still the same substance, which is AU or gold. Now, the cutting of diamond has to do with maybe it's being used to make a jewelry. We can cut diamond, one of the hardest materials. If it is being cut, that involves a change of shape. Very, very key. So these were pretty much very direct questions. Now, and they were based on physical change. Let's look at questions that particularly focus on the chemical change. Also, in a broader sense, they have to do with classification, remembering, these are not your type of questions where you need to scoop all the marks in an exam, right? And also, this one, it says classification of each one of the following chemical reaction. Remember, chemical reaction is a chemical change, right? So I'll give you a minute just to classify those in terms of synthesis or decomposition. I'll give you a minute for that. All right, guys, welcome back. Hopefully you've made your attempt on our very last question for today's session, which has to do with chemical change, new substances being formed. Now, our question has to do with classification into the two categories, either synthesis from simple to complex, and then from complex to simple, which is decomposition. So the burning process to form magnesium oxide. So we had magnesium and oxygen as simple elements. Now we have a compound. Now new substances have been formed. This is more complex. As a result of that, this will be a typical synthesis reaction. Now the rusting of iron, it forms iron oxide, right? Iron oxide, which is a compound. Now this compound is formed from simple elements, which is iron and oxygen gas. This is what we would call rusting, it has been indicated in that case. So this is another example of a synthesis chemical change or synthesis type of a reaction. So the burning of petrol. Petrol is a very complex substance, which contains a lot of carbon and hydrogen. We call them hydrocarbons, something that we'll discuss at a later stage. It forms simple substances like carbon dioxide and water, which are byproducts. But primarily, it releases a lot of energy, right, which is another thing that we can also make mention. So this is an example of a decomposition reaction. So sometimes we refer to it as a dissociation or decomposition, but the appropriate term at this stage is decomposition. Now, plants using carbon dioxide and water, so this is photosynthesis to make food in the presence of sunlight. So as you recall, this carbon dioxide is used by green plants and water, these simple substances. So this is photosynthesis, hence it falls under a synthesis type of a reaction. Right, folks. Now, that was it for today. The key things that we discussed is the physical and the very examples of physical change and what exactly happens when a physical change. We also compared and contrasted or showed some differences and similarities between, a physical change as well as a chemical change, with the very emphasis that the physical change involves intermolecular forces and the arrangement of particles. Yet, in a chemical change, it involves formation of new bonds. Hence, there's a relatively a large amount of energy involved, in bond breaking, as well as a small amount of or whatever energy is released during bond formation. Hence, we said that at the end of the day, both types of changes, as far as behavior of matter is concerned, to some extent, they involve a lot of energy. Right, guys, for myself, Temba Ngube, hopefully we had a splendid session for today. See you next time at the same place. Cheers and goodbye, guys.